Today I'm going to talk about what is a function. So you get introduced to the concept of a function when you're learning Algebra 1. But a lot of people still don't understand what it means by a function up until they're learning more advanced math classes such as pre-calculus or AP calculus. So if you are in your high school and you're taking Algebra 1 or 2 or pre-cal or AP calculus, you want to watch this. I want to start from the definition. Every time I explain something, I always focus on the fundamental definition. So we all know that function is something like fx is equal to x plus 1, gx is equal to x squared plus 3, something like that. But what is the actual definition of a function? So a function is actually the relationship between the input and output. And here, a lot of times an input and output don't have to be numbers, even though in math they are actually the numbers. So what are some real-world examples of the functions? How do you order something on a vending machine? Because you're not talking to someone. You push the button and then the vending machine is gonna give you the corresponding product once you swipe the card. So let's say there are 9 different options for a vending machine here. When you plug in a 1, you're going to get water. And when you plug in, let's say, a 2, you're going to get coffee. And when you push on the button A3, you're going to get milk. Okay, but then this is already a function because the button you push on are the inputs, and then the products you get are the outputs. So one input corresponds to one output. So this is what I mean by the function. The thing is, not every single vending machine works. Sometimes one vending machine might be broken, so when you push the button, it does not give you any of the products. Okay, then this vending machine is broken, which means this is not a valid function. If there is an input, there must be an output. One more thing is there must be only one output. What I mean by that is when you push a 1 in the morning, you get water. And then when you push on the button A1 in the afternoon, you get coffee. And then when you push on the same button in the evening, you get milk. Okay, then again, this vending machine is not working. Sometimes you get water, sometimes you get coffee, sometimes you get milk. This is not a valid vending machine. This is not working. So this is not a valid function. A function means that one input strictly corresponds to one output. So it's impossible that for one single input, you have many different corresponding outputs. That's not a function. Okay. But the other way, it's possible, which means when there are multiple inputs and then their output is exactly the same. So let's say for this vending machine, when you push on A1 and B1 and C1, every time you're going to get water. The first row are filled with water. It still works. So this is still a function. So it's possible for a multiple input to correspond to one output, but it's not possible that one input corresponds to multiple outputs. So this is the most fundamental definition of a function. Then in mathematics, why do we never see some examples like vending machine? Because in mathematics, in math classes, we use graph and equation to represent the functions, but they are not the only ways to represent the function. So there are multiple ways. So the most straightforward method to represent a function is a mapping diagram. So again, let's say for the vending machine, A1, A2, A3, B1, B2, and then they corresponds to, let's say, water and milk and coffee. We have 5 inputs and only 3 outputs. Well, it still can be a function if you mesh them in the right way. A1 and then A2 and A3, all of these 3 have the same output, which is water, and then B1 has the output of milk, B2 has the output of coffee. Well, this is a valid function. Why? Because for each of the input, there is one corresponding output. And for each of them, there is only one possible output. It's not like A1 produced both water and milk. No. So this is a valid function. So we use the mapping diagram and then the arrows to match the input and output. This is the most straightforward way. Something similar will be the table. So again, for the input, we have A1, A2, A3, B1, and B2. Okay, but for the output, instead of putting only 3, we will have to fill in every single row of this table. So A1 corresponds to water. The output is water. A2 also corresponds to water. A3 also corresponds to water. So instead of using arrow, now we're going to fill in just every single row and column of this table. And B1 corresponds to milk, and then B2 corresponds to coffee. So this is also a valid, but let's say this part is blank. Then it means for the input A2, there is no corresponding output. Then this is, again, not a valid function. So you need to make sure that for every single input, there is one corresponding output. That's the most important part of a function. But you don't see these two that often in math classes. In math classes, the two ways that are used most often are equations and graph. Well, what is an equation and what is a function? What's the difference between them? So many of my students always get confused because they think they're basically the same or they're interchangeable. Well, they have some similarities, but actually they are not. So equation is anything that left side is equal to the right side. It's connected by the equal sign. And it can be anything on the left side and anything on the right side. Well, it can be the numbers or it can be the variables. So let's say the variable x is equal to variable x. This is an equation. The number 3 is equal to number 3. This is also an equation, but neither of these two is a function. Again, function represent the relationship between input and output. And for this equation, there is no input or output. They're just the numbers. Left side is equal to the right side, or x is equal to x. Well, x can be an input or it can be an output, but there's no the other variable. So neither is a function, even though both of them are equation. They're valid equation. Or something like 0 is equal to 1 plus 1 minus 2. This is also an equation. It holds true, but again, it's not a function because there's no relationship between two variables. Then what is a function? Okay, so a function, again, it means there must be an input and output. So something like this would be a function. Output is equal to input plus 3. It means whatever the input is. Input can be a number. It can be a positive number. It can be a negative number. It can be a fraction. It can be 0, or it can even be a variable. Anyway, so input, every single input, if you add 3 on top of that, then you get the output. Then it clearly shows the relationship between an input and an output. So this is a function represented in terms of an equation. Okay, so a lot of times we use x and y to represent the input and output. Okay, we use the variables such as x, y, z. Sometimes we use something like s or t, u, w, any of them. Then how are they different from numbers? So numbers can be 0, 1, 2, 3. It can be 1/3, -9, 9, etc. So number means it represents a very specific value. There is only one possible value. So 1/3 will never be equal to 2. -99 is never equal to 0. It represents a very, very specific one single numerical value. On the other hand, variables means it's a changeable value. You can plug in a lot of different numbers. Well, probably not all the numbers. It depends on the scenario, but a lot of times you can plug in like 0, 1, 2, 3, a lot of whole numbers for x, or let's say all the positive numbers, or all the negative numbers, or all the non-negative numbers, etc. But as for the variables, you can pick whatever you want. They're just symbols. You can even put something like some English like number or like output. It's just that I don't want to write that much. So I want to save my time. So I just use one single alphabet to represent it. Here are some examples of a function which is written in the form of an equation. Y is equal to x plus 3. Okay, sometimes we also write it as fx is equal to x plus 3. So what does fx means? It means that x, whatever you plug in the parentheses, is an input, and then this whole thing is an output. So using x and fx is exactly the same as using x and y. The only difference is if once you use fx, it's a bit more clear, or it's more clear that this is a function, not just an equation. But in high school mathematics, you can use either way. Okay, then what does fx is equal to x plus 3 actually mean? It means that for every single input, you're going to have one corresponding output. And how do I get this output? Like, what output am I going to get? How you calculate this output is by adding 3 on top of the input. So no matter what number you plug in, you can plug in some number like 1, then you're going to get 4. You can plug in number 10, you're going to get 13. Or you can plug in number 99, and then you're going to get negative 96 as the output. Or you can plug in some other variables. So you can plug in some other variables such as y, f, y. Oh, so some people will think that, but y has to be output all the time. No, not actually. Again, x, y, z only represent the variables. So if you plug in some other variables such as y, then again, you're going to get y plus 3. Why? Because for this function f, the most important process is to get an output, you just add 3 on top of an input. And this input can be y, can be x, can be z. Or sometimes you can even plug in some other complicated variable, such as f z plus 2. Okay, so now it means that z plus 2, this whole chunk of thing, is the input. So again, how do we calculate an output? By adding 3 on top of an input. So now it becomes z plus 2, the input, plus 3. Or what about this? F of x squared. Okay, again, that's exactly the same. So now instead of x, now x squared is my new input. So on top of this new input, I just add 3. So fx squared becomes x squared plus 3. The last but not least, graph is also one of the most important methods to represent function. Okay, so again, for graph or for equations, these two methods are only valid when we assume that both inputs and outputs are numerical values. If it's a vending machine such as, oh, the button A1 corresponds to the milk or button B3 corresponds to coffee, then we cannot use the graph or the equation to represent a relationship between the input and output. So again, graph and equation only apply to the numerical values of input and output. In high school mathematics, we only deal with xy plane, xy Cartesian plane, two-dimensional plane, not the three-dimensional one. What's really important in high school math is you need to be able to convert between graph and equation. And you have to be very, very, very familiar with the conversion between these two. The equation provides a very concise way to calculate the input based on the output or output based on the input. But graph is more straightforward. You can see how the output varies as the input varies. That's the purpose of a graph. So how we draw a graph is by plotting some of the dots on xy plane. So let's say for the equation fx is equal to x plus 3. So you can come up with a table. When x is equal to 0, fx is equal to 3. When fx is equal to 2, fx is equal to 5. When fx is equal to negative 3, fx is equal to 0, and then it goes on. So you can just pick a limited number of points and then plot it out on the xy plane and then connect them using a smooth line. So 0, 3, 2, 5, -3, 0. Once you connect all of these 3 points, you are going to get a linear line like this. Then this linear line represents the function of fx. But this is an oversimplified representation of a function. So if you learn more advanced types of functions, such as rational function or radical function or polynomial functions, then there are other rules or properties that or other types of the test that you're going to learn to properly, to manually draw the functions on the xy plane. So now I've already explained the definition of a function. So now let's talk about how to identify or how to verify if a graph is a function or not. And then we call this vertical line test. So many of you have heard of this, but sometimes some of my students just don't understand what it means and why it works. Now let me try to explain. So now this is a xy plane, and then this is a random function. Let's call it gx. So what I mean by vertical line test is I have a vertical line, and then I'm going to move this vertical line across the graph of this function from left to the right. Okay, I'm going to gradually move it from left to the right, and then I will observe how many intersection occurs between this vertical line and this graph. Okay, so at this point, I have only one single intersection. Now I start moving this vertical line to the right gradually. You can observe that at every single point, there is only one intersection. And what is the meaning of this vertical line test? It means that for each of the x or each of the input, there is only one corresponding y value or the output. So this is exactly the same as the definition of a function. Again, function represent a relationship between the input and output. And then if I want to call a relationship function, then one input should correspond to only one output. Now let me try to give you an example of a graph that is not a function, but can be represented in terms of an equation. For this unit circle, I can use x squared plus y squared is equal to 1 to represent a graph. Okay, so now this is obviously an equation because it means the left side is equal to the right side. It's connected by an equal sign. This is an equation, but it's not a function. Why? Because it fails the vertical line test. So here is a vertical line, and then here is a vertical line. When I try to move it across the graph, okay, once it's attached to the leftmost side, there is only one intersection. But once I pass that point, you observe two intersections between this vertical line and the unit circle graph. This means that for one single x value, there are two corresponding y values. So let's say for negative 0.8. So this means that when x is equal to negative 0.8, y can be either one value or it can be another value. There are two possible outputs. Again, going back to the vending machine example, we know that this is not a valid vending machine. This vending machine doesn't work. Sometimes it gives you milk, sometimes it gives you the water when you push on the same button. So it fails. So we call that this graph fails the vertical line test, and thus this is not a function. Now let's talk about the composite function. So composite function just means that you combine multiple functions together. So there are multiple rounds of input and output. So let's say fx is equal to x plus 1 and gx is equal to x squared. Then you can combine them to form a composite function. So we can either write it as f of g of x, or we can write it as f of g of x. And what I mean by that is, first, x is the input. and then you're going to plug it in a function called g first to get an output of gx. But now gx becomes my new input, and then I'm going to plug it in this new function called f. So for the output, I will get something like f of g of x. Again, f of g of x means whatever that's in the parenthesis, gx means the input of the function f. So in the composite function, gx is both output and input. And then the order is you always start from something that's closer to the x. So when you compare f and g, g is much closer to x. So you plug in x into g first, and then you plug it into f. So f of g of x for this example is going to be f of x squared. That's the output of gx when you plug in x. And then f of x squared. Now, this whole part x squared is the input for the function fx. And function fx means that when you have an input, how you get an output is just by adding 1 on top of input. So now it becomes the input x squared plus 1. So this is the output. This is the final output of the function f of g of x.